Hello everyone, welcome to the Spintangle. Today we will be going on our next chapter that is called the numerical methods. Numerical methods. In this chapter, we will learn about different kind of approximation methods which are used in physics or mathematics or in also in computer science. Okay, these mathematical methods we will be discussing one by one. So first let's start with the very first topic, which is called Newton-Raphson method. Okay, the first topic called Newton-Raphson method. Okay, so let me tell you one thing, that what is Newton-Raphson method. Okay, Newton-Raphson method is a kind of iteration. It is a kind of iteration method. I am writing this. It is a kind of iteration method for obtaining more accurate value of say a measurement. It is a graphical method. Please make a systematic note. Okay, it is a graphical method okay. So what is iteration here? It is the English word in which iteration means repetition. Okay, this is all repetition. In case of various computational procedures in which the calculative methods or various enormous amount of data are collected. Okay, and in this kind of case we use iteration method to calculate the most appropriate value, which is also the approximation of the previous value. Okay, say if you have a value, say g is somewhere, g, that is gravitational acceleration is somewhere 9.9. okay, we use iteration method to make it more perfect. Say the second, after second iteration, after first iteration it becomes say 9.86, and after second iteration it becomes 9.81. This is the repetition. These are called iterations. Okay, these are called iterations. This is the initial. You may say this is first iteration. This is first iteration here. Iteration means first repetition, first iteration, and this is second iteration. And you may go one by one also in this manner. Okay, therefore the more accurate value will be obtained, and even after some repetition, some iteration, the value will be towards a fixed value, but not in case of mathematical values. You may fix on 9.81, but in this place, say here it will come that 625. Okay, and you will make another iteration, and that will become 9.81, say 421. Okay, and you will make another iteration and it will become 9.81, say 112, and you make another iteration, that not a final, there will be no final result of this case, because there will also 9.81, say this is 0003. Okay, this is also there is an error. Okay, you can easily see, not this is error, it will be, it will become more perfect in case of more iterations. Okay, this means iteration is an unlimited procedure. Okay, iteration is unlimited. How much iteration will be done, the more accurate will be the result, and there will be no extreme accurate point. Okay, there will be no extreme accurate point, because you can make a number more correct than you can think. Okay, this is what we do in our former calculus method, in which the limit is introduced. Okay, limit does not means that um, more accuracy. Limit means that how much we can go close to a result. Okay, how much we can go. In case of limit, we used to write this, say x tends to 0. This means we are proceeding towards 0. Okay, not we are not going at the point 0. Okay, we are going towards infinity, not at the point. We cannot reach this point, we cannot reach this actual 0. Okay, this is also a kind of iteration. Iteration means repetition. You repeat that, then conclusion is what? Conclusion is repeat. Repeat means iteration and accuracy. This is what the base of numerical methods. Various numerical methods are introduced to calculate more accurate result than we can think. Okay, more accuracy means repetition. You may repeat a problem. Why in case of practical, you all are students of BSc physics, and or in case of any practical lab based subject, uh, you are supposed to take um, various values of an experiment. Why there are various values you supposed to take? Because the more number of values will increase, the more number of results you are getting from the experiment, the more accurate will be the result. Okay, because you have to plot these results on a graph paper, and after the graph paper there will be an approximation graph. Say these are the points, say this is a graph, and there are your point. Okay, say there are your point. Then what you do, you draw a mean line. Okay, this is the most not this is the more accurate. We are closer to the most, but not the most. Okay, this is more accurate. The line goes in between these lines, but this is the more accurate. Okay, because this is after various kind of iterations. Okay, so not going to the fact that practical laboratory fact. Okay, so what we can do from this thing? So let's start with this thing. Okay, so the iteration method is okay. Let me write the rule first. The formula, which is for Newton-Raphson method. Okay, Newton-Raphson method. The general formula of Newton-Raphson method is given as x suffix n plus 1. This is x here. N plus 1 is equals to x n minus function of x n upon first derivative of the function of x n. Okay, in this n are what? n equals to 0 put when first iteration is done. This means first repetition is done. Put n equals to 0 when n equals to 1 when when second iteration is done, and so on. N is equals to 2 means third iteration is done. Okay, third iteration is done, and so on and so on. Okay, this is the general formula of Newton-Raphson method. Okay, so this is you have to remember this formula to do problems related to Newton-Raphson method. Okay, let me go to the
You have a
problems.
graph like this. Okay, say this is your graph, and you are going to do, sorry, this is, let's take another, this is the graph. Okay, so what you are going to do, say at this point, this is the point, at this point, what is the point, say this is the x0 point. Therefore the value of the function on this point will be what? The value of the function at this point will be f of x0. The first iteration will be given by this tangent. Okay, this is the tangent. Say, let me change the ink. This is the tangent. You have to draw a tangent on this point. Say this is the tangent, and this is what? This is the point after the first iteration. This is x1. Okay, this is more accurate than this. Okay, this is what Newton-Raphson method does. Say you are going to do this thing. Say this is the point. In this point, say you have the value x1, and you are willing to do that a tangent to be drawn on this point. I have did a wrong thing. Okay, you have to draw this tangent like this. Okay, a tangent, just a tangent. Say this is the tangent, and this point will be what? This point will be the correction. This point will be x2. Okay, anything what you can do. Okay, this is the Newton-Raphson method, and now we are going to do the problems. The problems in various um, the problems in various examinations. Okay, it is easier to solve. So let's take the first question. Okay, question. This is the important question. Okay. In finding the roots of the polynomial fx, that fx is given, this is the polynomial fx equals to 3x cube minus 4x minus 5 using the Newton rap using the iterative Newton-Raphson method. Okay, iterative, this means repetitive. The initial guess is taken to be x equals to 2. Okay, the initial guess is taken to be x equals to 2. In the next iteration, its value is nearest to this. Okay, this is what will be, we have to do this thing. To find this, what is our Newton-Raphson formula? Okay, Newton-Raphson formula. Our formula is xn plus 1 equals to xn minus f of xn by f prime of xn. Therefore, you need f prime also. Okay, what is the f prime? The first derivative of fx is what? This is 9x square minus 4. Put this thing on this formula. Okay, before putting, let's do, okay, put this thing on the formula. Xn plus 1 equals to xn minus f of xn becomes what? 3x cube minus 4x minus 5 in the numerator, and in the denominator there is a 9x square minus 4 term. Okay, so what we can do for first iteration, what we need to put for first iteration means first repetition, n has to be 0. Therefore the formula becomes x1 equals to x0 minus 3x cube 3x0 cube. This will be xn, I think so. This will be xn because in this term there was a fxn term. Okay, fxn. Okay, therefore here will be minus 4x0 minus 5, and in the denominator 9x0 square minus 4. So what you have to do, you have given that I think the initial guess is taken to be x equals to 1. This means x equals to 2 is the initial guess. It is given in the question. Initial guess. This means x0 equals to 2. Okay. This means initial guess means x0. Therefore, you have to plug them in this formula. Okay. x1 becomes 2 minus, what does it become? 3 into 2 cube minus 4 into 2 minus 5. I am correct or not? So what is the function? Okay, all things correct. 9 into 2 square minus 4. What is the value of this thing? 2 minus 24 minus, this thing is minus 13, I think so. And in this term there will be 36 minus 4. This becomes what? 2 minus, in the numerator there will be an 11, in the denominator there will be a 32. This means 64 minus 11, this means 53 by 64 minus 11. Okay, this means 53 by 32. You can check this thing out. Okay, 53 by 32, this means 53, 32 goes with 1, this means 32, here it is 21.20, this means 6, 190, this will be 190, and this will be 190, means, am I correct? 192, okay, sorry, 192, there will be 18, and this will be a 0, that means 1.67, okay, sorry, not 7, 5, this will be a 5, 160, and there will be a 200, this means there will be a 1.656. The value of this thing is 1.656. okay, therefore x1 will be what? After first iteration. Okay, the value after first iteration will be what? x1 equals to 1.656. okay, I am giving a homework to you. The homework is the previous question in the this is an important question. Please take a screenshot of this thing. Okay, of this problem, please take a screenshot. Okay, you are advised to take the screenshot. Okay, please pause and take a screenshot. Okay, let me move on to another special problem, which is not so hard to do. Okay, but a special problem. Okay, let me check my copy. Okay, for this is another question. For the given function f x equals to x square minus a, the recurrence relation by using Newton-Raphson method will be what? This is the question. Okay, therefore what you have to do? Okay, sorry, the options are options. So x n plus 1 equals to xn plus a by xn. This is the first question, first option. B, xn plus 1 equals to xn plus 2a by xn. Option C, xn plus 1 equals to xn plus 4a by xn, and the option D is xn plus 1 equals to 1 by 2 xn plus a by xn. Okay, these are the options. you have to do it carefully. Okay, this is important because I'm telling you what is the importance of this thing after the problem to be solved. Okay, so let's take the answer. We have the Newton-Raphson method. Read the question carefully. For the given function, there is a function given. The recurrence relation by using Newton-Raphson method will be what? The recurrence relation. Okay, these are the given recurrence relation. You have to match them with the Newton-Raphson method. Okay, so we have the Newton-Raphson method. Xn plus 1 is equals to what? Xn plus, sorry, Xn minus f of Xn by f of Xn plus, sorry, f of Xn and first derivative. Okay, this means what does it become? So the given function is what? The given function is f of x equals to x square minus a. Therefore, what you have to obtain first, you need to uh, differentiate this thing. Okay, this means it becomes 2x on the, put this thing on the formula, that will be xn plus 1 equals to xn minus x square minus a by 2x. There will be xn because the formula here the function is in dependent on the xn. Okay, therefore what you have to do here, okay, you can do anything at cross multiplication. You can do a cross multiplication. This means 2xn will be LCM and 2xn square minus xn square plus a, I think so, that is correct. This means it becomes what? Xn square plus a by 2xn. This becomes what? Xn plus 1 equals to 1 by 2. I think I can write it like this: xn plus a by xn. This is the answer. This is the option. Which one is the option? This is the option D. Okay, so this is a recurrence relation. This is why it is important. This is a recurrence relation. I am writing this thing. I'm writing, so Heron of Alexandria I think in okay, let me Heron of Alexandria used a pre-algebra version of this thing, you know, to not this thing directly, but this thing, the Heron of Alexandria used the pre-algebraic version of this thing as a recurrence relation. Okay, pre-algebra of the recurrence relation. Okay, in the age of 60 CE. Okay, age of 60 CE, in the time of 60 CE. Okay, but, you know one thing, that in the time of 60 CE, okay, so times ago, this formula was useful on this time, and also in this time, this is still the, this is, and I'm writing the language from my copy. Okay, this is a smart language here written. Okay, it is still at the heart of computer algorithms for finding square roots. Okay, a formula from 60 CE is useful in our era. Okay, this is quite interesting to know about. This formula is quite interesting. Okay, This is why I have taken this formula to solve in this class. Okay, so you have given one problem here. Okay, now let me give an example. Let me give an homework to you. I have given another homework on this thing, and which we have taken a screenshot, I think so. Okay, so I am giving a question: find all solutions of e to the power 2x equals to x plus 6. Okay, find all solution of this thing correct to 4 decimal places. By using Newton-Raphson method. Okay, this is homework to you. This is homework. Okay, so Newton-Raphson method is over. Thank you for being with us, and you are not the viewers are okay to viewers. There are approximately 60 viewers, 50 to 60 viewers average video. Okay, and you are not hitting the like button. Okay, this is quite annoying to me. Please hit the like button if you like.